this video goes over probability. So probability, some of the words that we need or the vocabulary that we need to be able to effectively solve problems in this unit are an event, which is an outcome from an experiment. We have an experiment, which is the process by which we obtain an outcome. And then a random experiment is one where there is uncertainty over which event may occur. We express the chances of an event occurring using a number between 0 and 1. 0 represents an impossible event, and 1 represents an event that is certain to happen. So we write P at A to represent the probability of an event A occurring. So the probability of event A is always between 0 and 1. So the first type of probability that we're going to talk about is theoretical. So this is when you talk about the probability of an event A occurring, and we use a formula here. So P at A is N at A, so the number of times A occurs over the number of possible outcomes. So A represents the event. This number, so N is for number of possible outcomes. And this is the number of times A occurs. Occurs starts with an O, even though we're talking about event A. Occurs. And then the P at A is the probability of event A occurring. So for example, the probability of rolling a 6 on a dice. So let's let A represent rolling a 6. This is a regular 6-sided dice. So then we have our probability of event A is 1 out of a possible 6 options. So in our theoretical probability, we also want to talk about an expected value. So how many times you would expect an event to occur. So let's take a look at this example here. We're now looking at a 10-sided dice with faces that are numbered 1 to 10. The event A that we're looking at is the number obtained is a multiple of 3. So in a fair-sided dice, these are our options, 6, 7, 8, 9, and we've got 3 possibilities that are a multiple of 3. So our probability of event A occurring is 3 times out of a possible 10 options. So our next question from that is, if I roll the dice 50 times, how many times would you expect a multiple of 3? Going back up to the top, we've got this statement here. If the probability of an event is P in N trials, you would expect the event to occur N times P times. So that means that we have our probability times our N, which is our expected value. We'll just label that as E. And so our probability we know is 3 out of 10. And we're going to multiply by 50 rolls, which is going to give us, 15 times. So therefore, we would expect 15 rolls to be a multiple of 3. Something interesting about the expected value is that it happens to be a whole number in this case, but it doesn't have to be. So in those first examples, that was theoretical probability. So that's what we think should happen. We also have experimental probability, which is how often things do happen based on an actual experiment. So what we use in experimental probability is something called relative frequency as an estimate of probability. The larger the number of trials that you do, the closer the relative frequency should be to the theoretical probability. So in experimental probability, same sort of approach, okay, but we write it as the probability of event A is the total times event A happens over the total times event was performed. So in something like rolling a dice, if you roll 10 times, okay, or let's say if you roll a 6, if you roll 6 times, you might get a 6 one of those times. That's theoretically what you would expect to happen. In an experiment, you might not get a 6 in those 6 times. As you continue to roll, so if you rolled 600 times, your experimental probability would come closer to matching that theoretical probability. So here's an example of experimental probability. This is data collected on the colors of cars that were passing the school gate one morning, and they're given in the table here. So the first question is estimate the probability that the next car to pass through the school gates will be red. So let's let A represent a red car passing through. Okay, and what we want to find is our probability of that event happening. So we need the number of red cars out of the total number of cars that went past the school gate. And this is going to give us approximately 0.326, or about 33%. Pretty low probability. Okay, looking at the next car. The follow-up to this is our expected value. So the next morning, 350 cars passed the school gates, and we want to estimate the number of red cars that we're going to see that morning, all based on the data collected in a previous experiment. So the number of red cars that we're expecting to see is our probability of event A times the number of cars. So our probability we already did, that is 45 out of 138. And we're going to multiply by 350 red cars. This gives us a whole number, which means that we'd expect to see 114 red cars go through the gates the next morning, which is about a third of that total, just like we expect from our probability. So we've covered theoretical probability and experimental probability. The last type is subjective probability, which there are no real calculations for this. This is an educated guess. So you might say, I am 85% confident that I will pass my first math test this semester. Something based on your previous experience that you're making a conclusion about. So those are the 3 types of probability that you should be able to calculate. There is experimental, which is probability calculated without doing any experiments. There is experimental probability, which is calculated after you do an experiment. And then there's subjective probability, which is making an educated guess based on your past or current knowledge or experiences.